easy to think of maths as the language of science and technology, but maths actually underpins everything from arts and crafts to humanities. So to tell us more about the impact of mathematics and its influence on life all around us, we're joined by Dr. Eugenia Cheng. Dr. Eugenia Cheng, thank you so much for joining us today. We're here at the amazing Royal Institution and you are about to give us a talk all about popular mathematics. But can you tell us a little bit about you and your background to kick us off?
Well, thanks very much for coming to have a chat with me. I am a mathematician, but I'm not just a mathematician. I started off as a normal sort of academic mathematician, but now I teach maths at art school in Chicago. I'm scientist in residence at the School of the Art Institute of Chicago, but I also write books. I do a lot of public speaking. I'm a musician, I'm a pianist, a composer. I make mathematical art installations, but I still do research in the very abstract field of category theory, which is what my PhD is in and what my original mathematical career was in.
There is so much that I want to ask you about, from being in an art school as a scientist to, I think it's art song that you particularly focus on, isn't it? But I'm going to try and park the music for now. I'm going to revisit that. I would love to pick up, first of all, on your area of expertise. Can you tell us what category theory is, what inspired you to get into it, and where we encounter it in our everyday lives?
Category theory is perhaps the most abstract part of pure mathematics. So that's the part that looks like it's the furthest away from daily life. I don't like saying real life because, well, what's real anyway? And we'll come back to that probably. But category theory is quite a recent development relative to the rest of mathematics because it's only about since the middle of the previous century, which is really young for maths. And the whole point is that maths is about finding patterns in science and in the world around us. Category theory is about finding patterns in maths. So it's one step more abstract than maths itself. And it says, maths says, if we see something similar going on in several situations, we can use our brain more efficiently by studying all of those situations at once at a slightly more abstract level, at the level of the pattern. And then when maths got sufficiently complicated, quite recently, mathematicians went, I see these similar things going on in these different branches of maths. Can we make a theory of that so that we can be more efficient about the way we do maths? And that's what category theory is. And I was always drawn to the most deep explanations of anything, all the way through school. I really, really loved science the most because to me that gave me the most satisfying explanations about the world. But then maths gave me the most satisfying explanations about science. And then pure maths gave me the most satisfying explanations about maths. And then inside that, category theory was the most satisfying explanation of maths. And then it reaches a kind of fixed point. That's a math joke. that a fixed point is where you come back to the same place each time you do something. And the thing that explains category theory is category theory. So it's like the deepest point of explanation of everything. That's how it seems to me, and that's why I was drawn to it.
This is all a bit mathception, isn't it? Category theory. My goodness, it's sort of like the dream about the dream about the dream. Oh my gosh. And what you're talking about, this insatiable sort of curiosity to understand the fundamental of the fundamental of the fundamental. It reminds me of that XKCD cartoon. I think it's number 438, and it's called Purity. And you've got, the biologist and the chemist and the physicist, and all the way at the end, the applied sort of mathematicians and the theoretical mathematicians are sort of like, hi, we're all over here. And so do you think that we place enough emphasis on really finding out about the fundamentals of things? Do you think we take too much at face value?
I think that it is, in a way, easier to say, how does this thing solve a problem in your daily life? How does this other thing solve a problem in your daily life? Whereas it's a bit deeper and a little more philosophical to say, what are the deep explanations and why do we even need to know them? Because it's true that you can get through your daily life without knowing any of those deep explanations about things. However, I think we can just understand everything better if we understand it more deeply. And that although abstract maths feels like it's removed from daily life, what you gain from it is you get to see more examples all united if you do something that's closely related to daily life, all it relates to is that one thing that it's relating to. But if you do something that's a broader pattern, then you can see the pattern more broadly, and you can unite a way broader range of things that you didn't really think of as maths before. And that is, to me, what abstract maths is about. It's about figuring out how to use our brains in a really, really good way. And then the usefulness is a bit more removed. I used to be really allergic to the word usefulness. It's like eating food because it's healthy. No, I want my food to be delicious. And I want my maths to be fun. But then I realized that I want my maths to be illuminating. And then I kind of came around and I thought, well, illumination is useful. Literal illumination, light is useful as well. Having light doesn't directly solve a problem, but it's way easier to fix things if you have good light. And that's, to me, what maths is about. It's about illumination and fun.
The way that you describe mathematics, the purest form of mathematics, you use incredibly sort of artistic words. And so I can almost see why you can be a scientist in residence in an art school, for example. I know from my brain is far too linear and logical, and I genuinely find kind of that way of abstract thinking quite alien to me, whereas you approach it so naturally. Do you think that comes with the creativity? You're musical, you're artistic. How do you approach such abstract problems within mathematics, and does that creativity help?
It's definitely a lot about creativity. I'm very wary of the word naturally, because who knows what we do naturally, right? Everything we do is practiced. And at least certainly at this age, that we've had so many influences through our lives. And so I think everybody could have practiced, and people are helped in different ways. And so I don't want anyone to think that you're either naturally this way of thinking or you're naturally not. But because I've spent a long time developing it, being fascinated by it, and being encouraged and helped in it, this is how my brain works. And I do think that it's partly, possibly partly something naturally, because I definitely got some of it from my parents. But who knows if that's just influences as well, because my mother has a very rational, methodical brain, and my father really doesn't. My father has a very expansive, random seeming. He makes loads of random connections between things to just make connections. And who knows, how does our brain make connections? That's a whole different topic. But I think creativity is partly about having ideas. And where do you get those ideas from? You can't get ideas by just making logical deductions all the time. And that's a really interesting aspect of maths, which is that, yes, it's built by logical deductions. That's how we prove things, only logical deductions. But how do you get the ideas in the first place? How do you come up with definitions? How do you come up with new structures? You don't do that just by making logical deductions, because you would never get anywhere if you did that. You have to just get ideas from somewhere. And that is the creative part. And it's really a shame that maths education usually leaves that part out. Usually, you don't get to invent things yourself, and you just have to follow the steps that somebody else has come up with. And of course, when you're in primary school or something, you're probably not able to invent genuinely new maths, but you could still go through the steps as if you were discovering it for the first time. And then you could feel the creativity that's in it, just like if you learn to cook, then hopefully you learn to follow recipes, but you also learn how to make things up yourself. And you don't believe that it's only about following recipes all the time. So I think that, unfortunately, maths is often presented as if it is not creative. But I want to show the creativity that's in it. And I can't help myself talking about it like that, because that's how it is to me. That's what it feels like.
Yeah. I think I do think it's actually really interesting the way that you talk about practice. You are a pianist and a musician. I, back in the day, was a grade 8 violinist.
Woo!
But I tried to pick up my violin the other day. Finally got it up on my office wall with my guitars and everything. And it's awful. The muscle memory is still there, but the tone is completely gone. And I do think, I look back to what I used to be able to do. And of course it was practice, because when I first started playing that, I probably sounded, like a herd of cats or something. So it is absolutely about that. And I do also find it really interesting that, you talk about this creative style. One of the things that actually reminded me of is the lack of experimentation, as you say. When we do experiments in science classes in school, they're not actually really experiments. They're just demonstrations. They're things that people are going through. And there is a right and wrong answer. That if you get it right, you've gotten to the end of the experiment. If you've gotten it wrong somewhere, you don't get what your friends get. And we almost don't reward that or reflect on that as being kind of real science and real research. But that idea of invention, I do think is really important. There's one more tiny story I will tell you, where when we were kids in school, we had to do these little invention tests and things. It was part of one of our art science crossover classes. And we invented this thing that could pick up leaves from a garden. It was this little sort of leaf picker-upper.
Oh.
And everyone laughed at us, going, nobody's going to be using that. A very popular company that is named after a rainforest advertised that to me the other day. And I thought, well, I was 35 years ahead of my time. That was great. So I do think that is absolutely something we should encourage more in education. So I am going to slightly move away from your sort of formal academic work, because you are an amazing science communicator as well. How do you sort of balance and how do you tailor your formal and informal teaching to all of these different audiences, especially around mathematics in particular? Because you span ages, teeny tiny, through kind of formal education of university and college, all the way through to all the popular science talks that you do for adults as well. How do you tailor all of that?
I do relish being able to speak to such different audiences. So thank you for noticing that. And I love all of them. I love talking to tiny children. I love talking to people who have math phobia, although I regret that anyone does, and I would love it if nobody did anymore. And I love giving hardcore research talks as well. And I think that it's important to remember that no audience is uniform. So even inside any of those audiences, there's always a range of people. And so then it's just a case of expanding that range a little bit in each direction. There's probably some maths analogy in there as well, where you change things by a little bit, and eventually you cover a very, very broad range. And I've always loved helping other people understand something that I understand. And that's another thing I've practiced. I've practiced it all my life. I used to help my friends at school when they didn't understand maths. But also one of the first things I did when I was a PhD student was start volunteering in primary school, helping with children's mathematics. And it was one of the saddest responses I got when I started doing that. Someone said, "Don't you think it's a bit of a waste of your expertise to help such young children?" And I thought, that is a shocking, I understand what you're saying, but isn't that terrible? What could be more important than using your expertise to help the smallest children right at the beginning? Because if you wait until later, something has already gone wrong for them before then. So I wanted to help at the forefront. And so I think that primary school teachers aside, I think primary school teachers are at the forefront of education, are the most important and the least valued out of everybody. So I also think that I loved talking to people at parties. I've always loved talking to people at parties about my work. And sometimes grad students say to me, "Oh, it's such a shame because when I go to parties, I can't talk about my work with them." And I thought, yes, you can though, just figure out how to do it. And so I talk to people a lot at parties. And that's how I first started practicing, trying out different ways of talking about it with people who weren't mathematicians. And if you are slightly responsive to their responses, then you look to see whether their eyes are glazing over. And so you don't launch in with a whole paragraph. You start with one sentence and see what they respond to, and then let that guide you. And then with all things, if you practice, then hopefully if you practice well, then you get better. And over time, because I've talked to many friends, so some of the friends would be scientists, so that's a little bit closer, but some of them would be English people, or would they be doing classics, so that's a little bit further away. And actually, sometimes it was hardest talking to the engineers because they had already a very strong view of what maths is, and it was very utilitarian for them. Yeah. If any maths isn't going to help with their specific work, what even is the point? So sometimes I thought they were actually the hardest audience. But having that practice of talking to a range of people is really what helped me get going. And just the whole idea of responding to the person who's in front of you.
Engineers being practical to the core is so on brand though, isn't it? I love that. It must frustrate you, somebody that loves maths so much. I'm already thinking we're going to do a maths joke bingo card for this interview because you keep peppering them in and I keep going, oh, that's brilliant. But it must frustrate you when people have that kind of, that blanket statement of, oh, I hate maths. So what can we do to kind of inspire people? What do you do, and what would you like to see more of?
Well, first I'd like to say it's not the people saying it who frustrate me. It's the fact that that is still a thing, that it's so widespread. But it's what drives me. It's why I do this work. And I think that first of all, we need to care about it, because there's still so many people think, oh, well, we don't need maths in our daily lives anyway, so it doesn't matter. So the first thing we do is need to care. And I think that we need to sit down and think about why we do education at all. And so what maths education is for, because there are so many different points of view on it. And if we are all trying to achieve something different, then no wonder we're all doing it differently. And so some people think it should all be about the basic skills you need to be able to calculate your grocery bill and do your taxes. And I just think that's an awfully narrow point of view, because education shouldn't be about just getting through your daily life. You know, we don't just teach people how to use washing machines and vacuum cleaners and how a mortgage works. And I think that if we teach how to think and how to learn, then that's much more broadly transferable. And if we understand that not everyone is motivated by the same things. And so some people say, oh, well, the way to make maths more interesting is to show the applications. And I think, well, not to everybody. That's not what made it interesting to me. And for some people, it's, oh, the way to make maths more interesting is. And so some people say it's to tell the history of it. And that will help some people. But I think the important thing is to persuade people that it can be for them, and that it doesn't have to be useful. It can be fun, and it can be about training the core of your brain, like being physically fit. And I often say that I think maths is like the core of thinking, that if you want to be physically fit, then everyone knows you need a strong core, even though your core isn't ever doing something by itself. There's no Olympics in core. It's just that it gives you better core strength, gives you more access to the rest of your strength. And better, I think, good mathematical strength gives you better access to the rest of your intelligence. And that if we pretend that everything we're doing is to be directly useful, then people immediately see through it. You know, the kind of fake real-life homework questions where someone says, you buy 87 watermelons and then you eat 16 of them. How many do you have left? It's completely unrealistic.
Sounds like a taskmaster task, doesn't it? Yeah. I do think that's actually really interesting to think of it as a sort of a core, almost a core discipline, a gateway to other things. It sort of reminds me of physics A-level, for example, where they have to teach that, but without any kind of advanced mathematical component, because they can't push people to do maths as well as physics. And physics, then, no offense to the physics A-level fans out there, but physics A-level is probably, for me, one of the least exciting ones that I did, because you couldn't dive into the most exciting bits of physics without the math.
Yes.
So what would you maybe like to see more of, or what would you like to see differently from the way that we teach these subjects? Should we keep them as siloed as we do, or should we have more crossover, not just with other sciences, but into arts and more creative endeavors as well?
It's a really good question, and I had the same experience of physics. I found it really unsatisfying, physics A-level.
You said it, not me.
No, you said it first. We're going to blame each other now. Like, no offense to the physics. Physics is great.
It was just great. Right. It could be so much better.
Right, and the same with maths. I mean, I was frustrated with a lot of maths at school as well, because it was very narrow. And I think that one thing is that I believe that we could focus more on techniques than on content, but also that there could be a way to stop making such clear boundaries between things. I'm not quite sure how, but it's very bureaucratic that we make boundaries. Really are bureaucratic, aren't they? Boundaries between countries, boundaries between counties, it's all administrative boundaries. And subjects is another one. That why do we need to pick specifically different A-level subjects? There are other countries where they don't do that radically, or where there's kind of the concept of science, or there's the concept of the arts, and it's more blended together. And then there's the whole idea, and I don't know if there are any countries that take project-based learning all the way up, but the idea of starting with a project and then doing all the things you need to do to make that project. Like perhaps you're going to emulate a cafe. So you learn how to make bread, and you learn how to make coffee, and then you learn about budgeting, and you learn about profit and loss, and then you kind of learn about marketing, and you design posters, and then you even maybe I read about one where they grew. Maybe they can't have grown trees. That doesn't make any sense. But they got wood and they made chairs, and so I think then you learn about some physics of the chair making, and you learn practical techniques, and then you also learn about geometry, and so then it's more about the project and all the things that go into it. And just that's so far from how we do it now.
Yeah.
I'm very idealistic. I don't know how we could get to there, but sometimes dreaming about what you would do idealistically can be a really helpful way to think about what it is that you're trying to achieve overall.
I think actually these sort of silos of knowledge and information and learning, and you will know this from your own research, they really persist sort of into academia and beyond. So much of the knowledge that we try and access is siloed. You know, of course, you've got kind of categorization, which is, you know, one thing, but we almost keep these things separate. It's very rare to find in an academic journal, for example, that is not focused on an incredibly niche topic. And you've got the broader journals, you know, things like Nature, for example, that will comment on lots of different things, but they're rare. And it's the same with things like conferences as well. So I think maybe dreaming of different ways of doing things is maybe the way forward. But how do we maybe turn that into action? How do we do it?
That's a really good question. And I think I got frustrated with trying to figure out how to change the system. And that's why I kind of went outside the system, left my normal academic job, and started writing books that could supplement the system rather than actually change the system. And so I have great respect for the people who are trying to change the system from inside it. And I think if more, it starts with education, right? And so if more people believe in it, then we can change things as we go along. The thing that often shocks me is the number of people who don't believe in it. And I kind of think a lot of them are clinging to the old ways because it's easier, and because everyone's overworked and underpaid, and because there isn't any funding or resources for massively changing things, and because it's so much work to design a course the first time, so much work, that of course you then want to use it for 20 years because it's so hard to make a new one. But then of course that means that people are using really stale old material because they're just desperately trying to avoid having to write another course. And so that's money problems and reward problems. And so the first thing we could do is fund education better, and then try to make it less bureaucratic about exactly where the funding goes, so that there is a possibility for these things. I mean, when I was inside institutions, they would have a drive for things like interdisciplinary, but then it was always very contrived, like, oh, you need one person from this department, one person from this department, we're going to write a joint proposal, and then we're going to go our separate ways again.
Yep. I think the reward system that you just touched on is a big issue, because I don't think the way that we reward success in places like academia are necessarily conducive to productive, collaborative, truly groundbreaking research. I wonder then, so you've talked about education formally and informally. Your books are such a delicious, and I use that word very specifically, entry point for a lot of people to kind of understand some really complex concepts within maths. Tell me about why you chose to write with the themes that run so strongly in your book. And I'll let you describe them all, because they're all different. They're all quite unique, but they're all just amazing.
Oh, thanks. Well, the first one definitely grew out of the teaching I was doing at the time at the University of Sheffield, where the students, a lot of them, it was kind of compulsory that they did some pure maths, but a lot of them didn't really want to. And so they weren't very highly motivated in it. So I had to work really hard to find slightly off-the-wall ways of keeping them interested. And I discovered that every time I mentioned food, they did wake up a bit. And so that was why the first book, How to Bake Pie, was about maths and food through analogies. And it wasn't, some people say to me, oh, it's like measuring, it's about scaling recipes. And I thought, oh no, it's the most boring aspect. But it's more metaphorical. It's about taking ingredients and putting them together to make something tasty. And then the second one was about infinity, because I have had so many conversations with children who are fascinated by infinity. And I think it's a great topic to show the open-endedness of, and the great distance between something that you can start thinking about, but you can never really get to the end. Oh no, that was terrible. And then things got a bit more political. And it was in 2016, I'd moved to America. There was an election, there was Brexit vote. Also, the politics was starting to get really, really polarized. Not starting, but I think it really went down off a cliff around then, because it became more acceptable to say some things. And I thought to myself, what can I contribute? Because I really believe it's important to take your expertise and contribute to the world as best you can with that. So not trying to do something that isn't in my expertise, but still making use of my expertise. And that's when I started really talking out loud in public and to my students about maths as a way of thinking that can help us decipher things in the world that don't necessarily seem mathematical, including massive political disagreements and social justice issues and polarizing arguments and people screaming at each other. And once I opened that floodgate, I couldn't really go back. I couldn't really go back to the, oh, maths is fun, it's like food. I had to be the maths is important, it's going to help us. And so then the next book was about gender issues, that's X plus Y. And because I've so often been asked, oh, what's it like being a woman? And what do you think about it? And when I was young, I didn't want to talk about it because I didn't want to draw attention to myself. Maybe you've had that experience as well, right? I just wanted to get my head down and do maths. And then I felt I had a responsibility to talk about it, because now that I had achieved some stability by not being part of an institution anymore, actually being mostly freelance means I'm not beholden to an institution. And also, because I have something of a voice now, I felt I had a responsibility to actually talk about it. So then I talked about that, and I wrote a couple of children's books because I love writing for children. I love children. And then I wrote a book to try and bring people into my research field. That's The Joy of Abstraction. And then the next one is the latest book, which I'm speaking about here at the Royal Institution this evening, called Is Maths Real? How Simple Questions Lead Us to Mathematics' Deepest Truths. And so it's not obviously political. It's all about how asking questions is really what maths is about, not just answering them, and about how open-ended some of the most basic questions can be. But I do bring social and political issues into it all the time, because now that I believe in it, I need to do that in order to keep doing what I believe in.
Yeah. I am so inspired by you, but I'm so frustrated by the system within which you had been working, where I almost feel like you had to leave that system. It was impossible for you to stay within it and change it from within, because it doesn't necessarily allow for or accommodate science communication in the way that you were doing it. It doesn't necessarily allow people to sort of speak about their lived experiences with that sort of freedom. What you just said was so relatable to me. I used to teach in an institution in London, over near the museums, and I really dumbed down sort of all the things that made me me, because it didn't feel like any of that was, it didn't have a place there. And I didn't feel that I would be taken as seriously within a group of people that maybe didn't share my demographic characteristics. And it's really tiring. It's incredibly tiring. And then you never really want to speak up because you don't want to cause trouble, you don't want to cause a fuss. You want the work that you're doing to be the thing that you're known for. But you never get the same platform from which to talk about your work than people that haven't been through those things. What would you like to see change in academia, in industry, in research generally, that could make it more inclusive of all people so they can be their most authentic selves?
This is something I wrote about in my book about gender, somewhat, about changing the system of rewards so that we reward what is really valuable rather than the things that we've always rewarded. And academia rewards huge grants. It involves massive prizes. And that is all, it's very all or nothing. It doesn't reward people who help other people. It doesn't reward mentoring. It doesn't reward collaborative efforts that lead to something else that wasn't specifically a huge grant, but helped somebody else do something. And I think another thing I'd like to see is much more valuing of communication of science, rather than people just staying inside their little box and doing their research, which doesn't mean I think everybody should be forced to do science communication, because we shouldn't people should be able to have different strengths, and everyone should be allowed to play to those strengths. But I think that if someone is able to do it and does it well, then that should be valued on behalf of everyone else. And in fact, I would like to see every single department have a full-time communicator position, and it should be somebody who is a specialist. And so it could be a half research, half communication position, or it could be two people doing half and half, or it could be someone whose full-time job it is to communicate the research of everyone in the department so that they understand the research and then communicate it. It does need to, I think it needs to be someone who is expert, at least to a certain extent, because it is hard to understand those things and then communicate them in a way that is still true to what they actually are. But I think if there were those jobs, because I meet a lot of young people now who really want to do that, but then they say, how do you do it? There's no path. There aren't any jobs. How can you do it other than just by randomly writing a blog or starting a podcast? And so I think that would be a really valuable position to have in every department. I think that there may be some starting to happen, but I remember talking to someone at an institution. It was near a museum.
It's funny.
It's funny.
It sounds really similar.
There are some institutions near museums, and at one point they said that they had tried to make a collaborative position between the university and the museum to combine research and communication, and that they had never done it because they just didn't think anyone existed who could have done it. And I thought, that's really shocking, because the reason that we don't see people doing it is because there aren't any positions. So if you don't make the position because you don't see anyone doing it, then we've got ourselves into a vicious circle.
Oh, wow.
And so I think that I would love to see that. I think that there are some positions a little bit like that. I believe there's one in the maths department in Cambridge that's a half, it's not, maybe not half communication, but it's half a normal position and then half something to do with diversity and inclusivity.
Oh, wow.
And so I think it is possible to do things like that, but we have to start by valuing them.
Yes, absolutely that. I think a lot of times, especially, from my experience in academia, when people understand the value of what you're trying to do, it becomes a nice to have, but until it's part of the reward system, the promotion criteria, workload models as well is a big one, because I think that for people that do research and teaching and any form of engagement or communication, these are not a third of a role. They're each almost a full-time role in themselves. And until we really place any value on that, I don't think things will change.
And we're so far from it, because I mean, the last I looked, even teaching wasn't really valued. And when I was last in a full-time position here, teaching wasn't part of the promotions. And it was only for, now it's a bit technical, but there's 4 levels of, so lecturer to senior lecturer, teaching was taken into account, but not from senior lecturer to reader. And that's the next step to professor. So you could never make it to professor without getting some giant research grant, but your teaching would never play a role in that. And the number of times I complained about it and tried to do something about it, and I was always told this stupid thing, well, the reason teaching isn't taken into account is because that's not a promotion. It's a change of status.
Oh.
And so it was a complete non-answer.
Oh my God.
And so until we actually value teaching, and what's a university for anyway? Some people, there's that awful joke that says, oh, a university without students is like a picnic without ants.
Wow.
I know, it is really awful. And it's one of the reasons that I left, because there really were people who still believed that teaching is just some thing you have to do on the side before you get on with your real job of research. And I think that is changing too, because I think that young people I talk to now who are coming through grad school, I haven't met one for a long time who didn't really care about teaching and communication. And so I think things can change. And so I do want to say, although I couldn't change things from the inside, like you say, I really had to get out to do it. I think that doesn't mean it's impossible forever. And I think that the more people inside who believe in it, it is going to change. And the people who don't believe in it are going to retire.
As awful as it sounds, yes.
Yeah.
I think an awful lot of this is generational, and I almost don't blame people. It's the experience they've had, it's the system within which they have kind of found their place, and they've established success on those terms. But I am excited that things are changing and have changed already and will continue to change. And I do think breaking down the sort of formality of education, you know, and the role of science communication changing and the value of it being understood better, I think really will have an impact on all of that. So I'm going to come to my final question now, which is kind of the future of mathematics and the future of our lovely planet and our global society. How do you see the role of mathematics in addressing global challenges like climate change and healthcare, and of course, economic inequality as well?
I do believe that maths is at the root of everything, and it's not just the numerical parts of the maths, but it's just the general use of logic as well. But most importantly, it's not just that we need the experts to be able to do it. We need everyone in society to be able to understand it and not be skeptical of it. And that's one of the reasons I think that maths outreach and education is so important. Because if we educate people and end up with adults who hate maths because they've been so put off it, who don't understand it, who think that it's just random rules or being imposed on them, then when they see mathematical things in the media or about the world around them, they will have an instant skepticism or run away from it or say that it's just people cooking figures or something. And so when we have people who don't believe in it because they've been put off it, then it's really difficult to communicate all of these important issues. And then we see people who don't believe in vaccines, who think that COVID is a hoax, they still think the earth is flat, and they think that climate change isn't real because look, it's a really hot day today, things like that. And so I think the main thing I want to say is that it's really important, not just so that we keep having experts to address it, but so that we can bring the whole world and society with us.
Dr. Eugenia Cheng, I cannot think of a better way to end this conversation. Thank you so much for joining us today.
Thank you so much.